General relativity, step by step. Last time I was making the observation that there's a distinction between geometry, as in curvature, and topology, which is a global organization for one space. And I made the observation that if you're a little ant trapped on this line here, you could tell that you weren't on the whether you're on the reals or a circle, just by making observations about the amount of space that you've got available, but you couldn't distinguish a circle from a knot, which is a non-standard embedding. And then I had a bit of a rant about how lots of pictures of relativity, lots of diagrams and images and icons of relativity would seem to indicate that space is embedded, or space-time is embedded in a higher dimensional sort of super space, which is not the case. It's not a helpful concept. I'm just going to spend a little bit more time. I'm going to talk about flat space in 2D. So I'm going to talk about flat space in 2 dimensions. So that's something like r squared. And again, we've got little ants, but these little ants are trapped. In a plane, and these guys live on a flat plane r squared. So there's the x coordinate and the y coordinate, and of course they live in an infinite space, so it's not compact or anything. And then we've got some other little insects which live on a torus. Now, straight away you say, well, there they are, there's the little insects and they're crawling around. Now, we know all about toruses. We know that we've got a little path that can go around there, and we've got another class of paths which go around here. But it's not flat. So the space of a torus it's not r squared because we've got a different global topology. However, I think of a torus like this. I think of it as a square, and we stitch together the top and the bottom and the left and the right lines like this. Now what that actually means is that if I'm sitting here by the edge, I can go this way, and because I'm stitching together this and this line, I will pop out here. And likewise, if I move up here, move up there, I will pop out up here as well. And of course, these two spaces are, oops, that's red. These two spaces are the same, because if I were to actually get this, I would to identify this point with this point, I'd just curve it round. I'd just see if I can draw that. Yeah, there we go. Is that what it looks like? I think I'm missing a line. Oh yeah. Yeah, so I could do that, but then again, so I'm matching that with that, and that corresponds to stitching these surfaces together, these lines together in that line. And then I'd want to stitch those two together, so I'd have to pick it up and squoosh it round, and that would turn me into a regular torus. So this is an embedding of the torus into 3-dimensional space, which has introduced curvature. But there is no sense in which the torus is associated with curvature, because if I think about the torus like this, with no restriction on, or no requirement for me to embed my surface into 3-dimensional space, then the surface is flat. So what I'm trying to say is that if you do not need to embed your 2D surface into 3D, then flat space might be toroidal or just the plane. And I think that's quite a powerful statement there. From the observation of flat space, if I then say you don't have to embed it in a higher dimensional space, you can use this trick here, you cannot tell from local flatness whether your global topology is that of a torus or that of the plane. And it's the same with us. We could take local measurements that indicate that our our universe is a bit like this sphere here, and that is no information about the global topology of your universe. These are very, very, very difficult concepts, and I say again that you are fighting pictures like this, and pictures like that, and pictures like this gravity well here, and pictures like this Flam's paraboloid. You're fighting that because you're almost conditioned to think that general relativity is about how you can embed Minkowski space in a higher dimensional space, and you can't do it. There is no meaningful sense in which Minkowski space is embedded in a higher dimensional space. No sensible way at all. So I'm going to stop there, and what I'm going to do next time, I'm going to consider this spherical picture here, and I'm going to consider the other solution as well. Where was it? The hyperbolic solution with positive values of k. I'll consider that next time, but for the moment I'm going to stop here. Where's my torus? Where's my torus? There it is. Stop.